When we observe the 19th century through textbooks, we are shown a world that was still learning how to industrialize. Steam engines were new, electricity was rare, and most labor was done by hand. According to official history, this was a transitional age, not yet modern, not yet technologically mature. When we step outside the pages of history books and instead observe the physical world that survived from that era, we encounter a contradiction so large that it cannot be ignored. Across continents, massive structures built during art attributed to the 19th century stand with a level of precision, scale, and engineering sophistication that challenges the limits of what that time period is supposed to have been capable of. These buildings are not minor constructions or rural architecture. They are monumental, they are complex, they are durable, and most importantly, they appear far more advanced than the tools and methods officially assigned to their builders. This raises a fundamental question that is rarely asked in mainstream historical discussion. Are these structures truly the product of 19th century technology as we are told? Or are we observing something older, more advanced, or misunderstood? This question does not require belief or speculation. It requires only observation, because buildings do not lie. They do not reinterpret themselves over time. They remain fixed, silently preserving the technological knowledge embedded within their walls, foundations, and proportions. When we study these structures carefully, we are not reading opinions, we are reading physical evidence. The 19th century, cities across Europe, North America, Asia, and other regions experienced what official history describes as rapid urban development. Entire districts appeared within decades. Government buildings, train stations, cathedrals, universities, hospitals, and palaces were constructed at an unprecedented scale. What is remarkable is not just their size, but the uniformity of their quality. These buildings were not experimental or crude. They were refined from the moment they appeared. There is little evidence of architectural trial and error. Instead, what we see is confidence, as if the builders already knew exactly what they were doing. Let us begin with scale. Many 19th century structures involve stone blocks weighing several tons, placed with millimeter-level precision. Columns rise multiple stories high, carved from single pieces of stone. Domes span vast interior spaces without visible reinforcement. Foundations extend deep into the earth, engineered to support enormous weight for centuries. Even today, constructing such buildings requires advanced machinery, heavy cranes, laser measurements, and reinforced materials. Yet, we are told that in the 19th century, these feats were accomplished largely with human labor, simple pulleys, wooden scaffolding, and basic surveying tools. While human labor is powerful, it does not explain precision. Strength alone does not produce mathematical perfection. When we observe the stonework in these structures, we notice surfaces that are flat beyond what hand tools are typically capable of producing. We see joints so tight that a blade cannot be inserted between stones. We see symmetry repeated not once or twice, but hundreds of times across a single facade. This level of consistency suggests standardized processes, not improvisation. Suggests that the builders were following precise rules, measurements, and systems that are rarely documented in historical records. Another critical issue is speed. Many of these structures were reportedly built within timeframes that seem unrealistic even by modern standards. Buildings that today would require decades of planning, engineering, and construction were allegedly completed in 10 to 20 years. This includes not only the structure itself, but also the quarrying of materials, transportation across long distances, carving, assembly, and finishing. Transportation alone poses a major problem. Heavy stone blocks were moved across rivers, mountains, and undeveloped landscapes without modern vehicles. Official explanations often reference horse-drawn carts and manual hauling, yet offer little detail on how these methods achieved such efficiency on a massive scale. Beyond scale and speed, there is the issue of global similarity. When we compare 19th century architecture across different continents, we notice patterns that are too consistent to dismiss as coincidence. Government buildings in Washington, D.C. share striking similarities with those in London, Paris, Rome, and St. Petersburg. Train stations in India resemble those in Europe. Universities in Australia echo the architectural language of ancient classical forms. Columns follow the same ratios, domes use similar curvature, facades obey the same rules of symmetry. Official history explains this by saying that architects copied styles from classical civilizations. But copying style does not explain copying engineering solutions. Aesthetic imitation does not produce identical structural logic. This raises an important possibility. What if these buildings were not independently designed, but rather based on an existing architectural system that was already well understood? What if the 19th century inherited more knowledge than it created? This would explain why buildings appear suddenly, fully formed, without a visible learning curve. It would also explain why similar construction techniques appear across regions that had limited communication at the time. Inside these buildings, we find even more anomalies. Advanced ventilation systems are hidden within walls. Natural airflow designs regulate temperature without electricity. Heating systems distribute warmth evenly through massive interior spaces. Some structures maintain comfortable indoor climates year-round, using nothing but architectural geometry and material choice. These features features are often attributed to clever design, yet their complexity suggests deep understanding of physics, thermodynamics, and acoustics. In many cases, modern engineers studying these buildings admit that replicating such systems today would require detailed analysis and advanced modeling. Another rarely discussed aspect is durability. Many 19th century structures have survived earthquakes, floods, wars, and fires. Their foundations remain stable, their walls remain true. Meanwhile, many modern buildings constructed with advanced materials show signs of degradation within decades. This contrast raises questions about what has been lost in modern construction practices. If our technology is superior, why does our architecture often prove inferior in longevity? One of the most puzzling elements is the lack of detailed documentation. For projects of such magnitude, we would expect extensive records, engineering, diagrams, construction manuals, technical explanations, and named experts. Instead, historical records are often vague. We are told that buildings were constructed by large numbers of workers, under the supervision of a few architects whose contributions are often poorly defined. The actual methods used, how stones were cut, how loads were calculated, how alignment was achieved, are frequently described as lost or unknown. The idea that such critical knowledge disappeared within a generation strains credibility. As we observe these structures, we must also consider the historical context. The 19th century was a time of upheaval. Wars, revolutions, fires, and urban redevelopment destroyed countless records. Cities were rebuilt, renamed, and reclassified. It is entirely possible that earlier structures were repurposed, reattributed, or modified, and then absorbed into a simplified historical timeline. This would not require deception, only loss and reinterpretation. The question, then, is not whether official history is wrong, but whether it is incomplete. History is written based on surviving records, not necessarily on complete truth. When physical evidence contradicts written accounts, the responsible response is not dismissal, but investigation. The buildings themselves become primary sources, silent but reliable. As we move deeper into this topic, we will examine specific examples, engineering features, and global patterns that challenge conventional explanations. We will not rely on speculation or sensational claims. We will rely on observation, comparison, and logic, because the structures of the 19th century still stand before us, inviting scrutiny. And the more closely we observe them, the more difficult it becomes to accept simple explanations. This is not about rewriting history. It is about expanding it. It is about acknowledging that human capability in the past may have been greater than we are comfortable admitting. And it is about recognizing that progress is not always linear. Sometimes knowledge is lost. Sometimes civilizations forget what they once knew. The buildings remain, waiting for us to ask better questions. And as we continue, one truth becomes increasingly clear: the 19th century, as preserved in stone and steel, tells a story far more complex than the one we were taught. As we move further into the 19th century, the question is no longer whether these structures are impressive, but whether the official explanations fully account for what we are seeing. When historians describe this era, they emphasize progress. Through experimentation, society's learning through mistakes, slowly refining technology, but the architecture of the time does not reflect uncertainty. Instead, it reflects mastery. Buildings appear complete, optimized, and consistent. From the moment they emerge in the historical record, there is no visible developmental phase, no rough drafts, no transitional designs. This absence of architectural evolution within the century itself is one of the strongest indicators that something does not align with the conventional narrative. Consider engineering knowledge required to construct massive domes without internal steel reinforcement. Domes, such as those found on government buildings, cathedrals, and public halls, rely on precise distribution of forces. A minor miscalculation would result in collapse. Yet these domes were built repeatedly across continents with remarkable success. Today, engineers use computer simulations to model stress points in such structures. In the 19th century, we are told these calculations were done manually, often based on inherited rules of thumb. But rules of thumb do not explain near-perfect consistency across unrelated regions. Consistency suggests standardized knowledge, not isolated genius. Another critical observation emerges when we examine infrastructure beneath these buildings. Underground tunnels, drainage systems, and foundation networks were often constructed alongside the buildings themselves. These systems required extensive planning and coordination. In many cities, 19th century sewer systems remain in use today, having outlived multiple generations of modern upgrades. These systems display foresight, anticipating population growth, waste management needs, and long-term maintenance. It is difficult difficult to reconcile such planning with the image of a society still figuring things out industrially. Transportational materials presents another unresolved issue. Stone, used in monumental buildings, was often quarried far from construction sites. In some cases, materials traveled hundreds of kilometers. The logistics required to extract, transport, and precisely place these materials would have demanded not only physical labor, but advanced organizational systems. Timelines had to be synchronized. Measurements had to remain consistent from quarry to site. Damage had to be minimized. Official history acknowledges these challenges, but rarely explains how they were overcome repeatedly, efficiently, and at scale. When we observe 19th century construction sites depicted in paintings and photographs, something else becomes noticeable. The tools shown are often surprisingly minimal. Simple cranes, wooden scaffolding, and ropes are common. What is missing are the intermediate technologies that would logically bridge the gap between basic tools and monumental results. This gap invites scrutiny. Either the tools depicted are incomplete representations, or the methods used were more advanced than commonly portrayed. Another anomaly appears in the workforce itself. Historical accounts frequently emphasize massive labor forces, thousands of workers engaged in construction, yet labor quantity does not equate to labor quality. Precision stone cutting, advanced geometry, and structural engineering require training, not just manpower. If such specialized knowledge existed among workers, where did it come from? Where are the manuals? Where are the training institutions? Where are the detailed records of this expertise being passed down? The silence surrounding these questions is striking. Furthermore, many of these buildings incorporate symbolic and mathematical elements that suggest deeper intent. Proportions often follow classical ratios associated with harmony and balance. Alignments correspond with cardinal directions. In some cases, buildings appear to be positioned according to geometric grids that extend across entire cities. This level of planning implies centralized design and long-term vision. It is difficult to believe that such comprehensive planning emerged spontaneously across multiple nations during a single century. Urban layouts from the 19th century further complicate the picture. Cities were often redesigned with wide boulevards, symmetrical layouts, and monumental axes. These redesigns required the demolition of existing neighborhoods and the coordination of massive resources. Official narratives describe these projects as responses to modernization and public health concerns. While these motivations are plausible, they do not explain the speed and uniformity with which such transformations occurred. Nor do they explain how societies with limited technology managed such large-scale urban engineering without significant recorded failure. Inside many 19th century buildings, we also find evidence of advanced acoustic engineering. Concert halls, parliamentary chambers, and courtrooms were designed to project sound clearly without amplification. Achieving such acoustic performance requires precise understanding of wave behavior, material interaction, and spatial geometry. Modern acoustic engineering is a specialized field, yet these principles appear to have been applied intuitively, repeatedly, and successfully in the 19th century. This again raises the question, where did this knowledge originate? Another overlooked detail is standardization. Windows, doors, columns, and decorative elements often conform to consistent dimensions within and across buildings. This suggests the existence of standardized measurement systems and prefabrication processes. Standardization increases efficiency and precision, but it also requires planning and infrastructure. Official history tends to attribute such consistency to craftsmanship traditions, but tradition alone does not produce global uniformity. As we examine photographs from the late 19th century, we sometimes see cities already filled with grand buildings shortly after their supposed founding. In some cases, these cities appear fully developed almost overnight. The streets are lined with monumental architecture, yet population records suggest relatively small communities at the time. This discrepancy raises questions about who built these cities, for whom they were built, and how they were populated so quickly. The issue of maintenance also deserves attention. Many 19th century structures have required surprisingly little structural repair over time. While facades may weather and interiors may be renovated, the core structure often remains intact. This durability indicates not only strong materials, but deep understanding of load distribution, environmental stress, and long-term degradation. Such foresight is often attributed to experience, yet experience requires time. Where did this accumulated experience come from? One possible explanation is that the 19th century inherited architectural knowledge from earlier periods that are poorly understood or underdocumented. Rather than inventing these techniques from scratch, builders may have adapted and reused existing structures and methods. This would explain why certain buildings appear older than their official dates, why styles seem fully matured from the outset, and why documentation is sparse. It would also explain why some buildings appear to have been modified rather than originally constructed during the 19th century. This This perspective does not require assuming deliberate deception. Historical records are shaped by what survives and what is recorded. If earlier knowledge was lost through war, disaster, or neglect, later generations may have simply reinterpreted what they found. Over time, these reinterpretations solidified into official narratives. The buildings themselves, however, retain physical clues that resist simplification. As we continue to observe, it becomes clear that the 19th century may represent not a beginning, but a transition, a period during which older systems were still visible, still usable, but gradually forgotten. Industrialization may have replaced certain techniques, but it may also have obscured others. In focusing on new technologies, societies may have neglected to preserve the knowledge embedded in older structures. This brings us to an important realization. History is often written around invention, who invented what and when, but architecture is not only about invention, it is about application, it is about systems that work. The 19th century structures we observe worked extraordinarily well. They provided shelter, functionality, and beauty on a scale that remains impressive. Today, that level of success suggests that their creators were not experimenting, but executing well-understood principles. As we move forward, we will examine specific types of buildings, train stations, government halls, educational institutions, and religious structures, and analyze the shared features that defy simple explanation. We will also consider what may have happened to the knowledge required to build them, and why modern societies struggle to replicate their qualities despite superior technology. What becomes increasingly evident is that these buildings are not anomalies. They are part of a pattern, a global pattern that challenges the idea of linear progress and invites us to reconsider what we think we know about the past. The 19th century, when observed through its architecture, appears less like a dawn of modernity and more like the fading echo of something greater. And as we continue, the silence of these structures grows louder, urging us to look closer, question deeper, and remain open to possibilities that official history has yet to fully